This video is about ammonium salts, why they're important, and how to find them. So oftentimes amines are in their ammonium salt form in medications, especially because they're a lot more soluble in that form. So here is an example, Sudafed, phenylephrine hydrochloride. So when we hear about these hydrochloride versions of medications, it's oftentimes that we're making the salt so that this particular medication or drug is more water soluble. So what does this look like? Well, we've got our benzene ring, and off of our benzene ring is an alcohol group. And then 2 carbons away from that off of the benzene ring is CH with an OH on it and also bonded to CH2, which is bonded to N that has 2 hydrogens coming off of it and a CH3. So it's overall positive, and then there's a Cl minus. That's your chloride ion. So it's hydrochloride because the salt was formed from having the amine react with hydrochloric acid. So we're going to talk more about that. But suffice it to say, our nitrogen right now has 4 bonds, so it's overall positive, and our Cl minus is negative. I don't really like how messy, so I'm just changing that. Okay, so we end up with our nitrogen having 4 bonds, so it's positive, and our counter ion or our chlorine. So, it's kind of interesting. This nitrogen is a secondary amine. And, let's just put it in writing. We've got our cation is our whole molecule, and then our Cl minus is our anion. And, let's just really make it clear. We like these ammonium salts because these are a lot more water soluble. That's super important for a lot of medications. Okay, let's look at Benadryl next. We've got a carbon that has 2 benzene rings attached to it and a hydrogen. Then it's attached to an oxygen and to another carbon, CH2 and a CH2. So by the way, the oxygen that was in the middle there, that's an ether oxygen. Okay, and CH2 is attached to a nitrogen that's attached to 2 CH3s and a hydrogen. So it's got 4 bonds to it. It's overall positive. It's got 1, 2, 3 bonds to carbon, which makes it a tertiary amine. And then it's got a Cl minus counter ion. So this is another ammonium salt of an amine. So, our definition of salt is about having a cation and an anion. So if our amine is in its cation form, and then we've got our anion, or chloride anion, we've made a salt. Okay, so Sudafed and Benadryl were both ammonium salts. But now we have just a few more amines to identify before we move on. So these are back to our old-fashioned amines, not ammonium salts. But they're important examples. We've got methamphetamine. It's often referred to as meth, just for this one methyl group on the amine. So there is, like the name sounds, a methyl group, but the molecule's bigger and more complicated than that. Our science terms just get kind of wrecked in everyday life every once in a while. But we've got our nitrogen with our CH3, so there is a methyl group to give it its characteristic name. And then our N is also bonded to an H, and then it's bonded to another CH. The N is bonded to a CH, which is bonded to a CH3, and the CH is bonded to a CH2, which is bonded to a benzene ring. So back to our nitrogen, it had carbons in 2 directions, so it's secondary. So we've got this secondary amine in methamphetamine. And that secondary amine does have a methyl group on it, so that's part of where its name comes from. And then over here, we've got phenylalanine. Okay, so it's got a benzene ring. Connected to the benzene ring is CH2 and then CH. On the CH is an NH2, and then on the CH is a C that's double bonded to O and bonded to an O and an H. So C double bond O bonded to an O and an H, well, that's a carboxylic acid. We recognize that functional group. And then the NH2 coming off of the molecule, that's an amine functional group. It's bonded to one carbon, the nitrogen is, so it's a primary amine. So this amine and carboxylic acid make phenylalanine an amino acid. These are super important in our building blocks for proteins. So we're going to keep studying the amine group in terms of studying amino acids as well. Okay, so let's talk about acid-base reactions of amines. Ammonia and amines are bases because of the lone pair of electrons on the nitrogen atom. So if we redraw nitrogen, has 5 valence electrons. Let's put them around nitrogen. 1, 2, 3, 4. And the 5th one will double up and will make a lone pair. So the 3 electrons that don't have partners can make nitrogen's 3 bonds. The 2 electrons that are paired up, that's the lone pair. And it's that lone pair that makes it basic. And they are weak bases because that amine group will ionize just ever so slightly in water. So it's just a weak base to form ammonium and hydroxide ions. So amines with 1 to 5 carbon atoms are water soluble because they can hydrogen bond with water. And larger amines, like 6 or more carbons, are water insoluble. Okay, so here we've got an amine, an N, with its lone pair bonded to 1, 2, 3 R groups. That makes it a tertiary amine. Plus water, so it reacts with water. And, you know, it's a weak base, so this is going to have equilibrium arrows. It's a reversible reaction. And what happens is the nitrogen goes and picks up the hydrogen from water, but it helps to think of water as H bonded to OH. So rewriting it as HOH is kind of helpful. The lone pair on the nitrogen, those electrons will draw an arrow from them over to the hydrogen of water. They'll pick up the hydrogen. So the lone pair electrons from nitrogen form this new bond to hydrogen. Those electrons are over here on the product side as a new bond to hydrogen. Now, nitrogen doesn't want 4 bonds, so it's going to be overall positive, and that's going to leave behind the hydroxide ion. That was an ion that we worked on learning with polyatomic ions, but it's OH minus, or hydroxide ion. So water breaks up into H with ammonium, so think of it as like H plus, which makes, you know, the amine go from neutral to picking H plus, makes it overall positive. And then that leaves behind OH minus. So we have an amine and water makes ammonium and hydroxide. So amines with water make ammonium and hydroxide. Amines will react with acids, such as hydrochloric acid, to form ammonium salts. Ammonium salts are soluble in water. So these guys are totally soluble in water. For this reason, amines used in medications are usually in their soluble ammonium salt form. So these ammonium salt forms are really important for medications because they're not usually the amine itself. So then you'll have an amine. This one's shown with an R and 2 H's. Well, with just one R, it's a primary amine. Reacting with hydrochloric acid, HCl. So remember that there is a lone pair on this nitrogen, even if it's not drawn in. And that lone pair can go and pick up the hydrogen of HCl. This HCl bond actually breaks and chlorine gets those electrons. When it picks up the hydrogen, it picks up an H plus. So now the amine is overall plus. The nitrogen doesn't want 4 bonds, so that's why it's positive too. And then Cl minus is the counter ion. So we've made an ammonium salt here. And again, these ammonium salts are pretty important for medications. So let's look at a couple of examples. In this example, we have a carbon with 2 benzene rings bonded to it. And that carbon has 1 hydrogen as well. And then it also has an O that's bonded to a CH2 and a CH2, and then it's bonded to a nitrogen. And that nitrogen has 2 different methyl groups coming off of it as well. So since this nitrogen is bonded to carbons on 3 sides, it's tertiary. And it's implied that there's a lone pair on this nitrogen. It's going to react with HCl. So the lone pair on the nitrogen is going to pick up the H from HCl. What are we going to do then? Well, we're going to copy this whole molecule, starting with the carbon having 2 benzene rings coming off of it. That carbon has a hydrogen, and then it has O, CH2, CH2, and then it has a nitrogen that has 2 CH3s. But now the nitrogen has picked up a hydrogen, and it's overall positive. And then you'll have a Cl minus counter ion, so you have made an ammonium salt. Almost spelled it wrong. An ammonium salt. Some people call these ammonium salts. Sometimes you'll see these called amine salts. It's really the same thing. Call it either an ammonium salt or an amine salt. Let's look at one more example. Here's a benzene ring. Bonded to the benzene ring is CH2, then a CH that has a CH3 on it, and the CH is also bonded to an NH, and that N also has a CH3 on the end. So the N goes and picks up an H from HCl. What do we do to make the products? We copy our whole amine. So our benzene ring, CH2, CH, has a CH3 off of it. Go back to the C and put an N and one H, and now put a second H, and then the CH3 group it had. Since it picked up another H, it's overall positive, and the chlorine, the Cl minus, will be our counter ion. So again, we have another ammonium salt. And these will be more water soluble, which is why medications like the Benadryl type medications might say hydrochloride at the end, because they could have potentially been made with hydrochloric acid to make the soluble ammonium salt out of that molecule.